These limits together, evaluating limits of graphs or functions by using their graphs. So remember, for a limit to exist, the limit has to match from both left and right. So this first one, let's look at A together. So this one right here, the blue graph is the one of f. The limit as x goes to -5. So we find -5 here, and we look to see what's happening from the left. We see that it's approaching 7. And then from the right, we see that it's also approaching 7. We don't care what actually happens at -5. We just care about where it's headed. So the limit here is +7. Okay, now let's look at limit as x goes to -2. So -2 is here. From the left, it's going to 2. Let's do it here. From the left, we're coming down towards 2, and from the right, we're going up towards 2. So the limit as x approaches -2 of f is 2. Good. Now let's look at the limit as x goes to 1. So again, we see how it's split. From the left, it's going to -3, and from the right, it's going up to -4. So here, the limit does not exist because the left and the right-hand limits don't match. All right, let's look at limit as x goes to 4. From the left, we're coming down towards -2, and from the right, we're also headed towards -2. And it doesn't matter that it's not even defined at 4. It only matters where it's headed. So this one is -2. Great. Let's look at the graph of g, which is this red graph. So here we're looking for the limit as x approaches -1.5. So somewhere about there. We'll say that's -1.5. And we see that as x approaches -1 from the left, my y is going down towards 3. And similarly, as we approach -1.5 from the right, my y is going up towards 3. So 3 here is our limit. Perfect. Now if we look at 0, as x approaches 0 from the left, our y is headed down towards 2. And as we approach 0 from the right, our y is headed down towards -2. Doesn't matter what happens at 0, just where it's headed. The left and the right don't match, so this is a does not exist. Good. All right, the limit as x approaches 2 of g. So again, we see that we have unmatching left and right hand limits. If we come from the left, we're headed up towards -1. And if we come from the right, we're headed towards 4. So the limit as x approaches 2 of g of x does not exist. Lastly, x approaches 4. From the left, it's headed to 4. From the right, it's headed to 1. Those don't match, does not exist. All right, now let's look at the limit of the composition of functions. All right, so here, if the limit exists inside, we can just plug that limit into the interior and evaluate the function. So let's first see if the limit as x approaches -1 for g exists. And it does. We've already seen that. So it's about right there. So because the limit as x approaches -1 of g exists, this is equal to f of the limit as x approaches -1 of g of x. So we can evaluate that limit and then plug it into the function. So it's f of, what do we say it went to? As we approach -1, it looks like we're going to 2.75. So f of 2.75, it looks like. So then we just come over here to 2.75, and maybe it is, we'll just approximate and say that it is 1. Okay? Now on this next one, we already know that the limit doesn't exist for g of x, so I can't just plug it in and evaluate it. But it also doesn't mean it doesn't exist. So now we're going to look at the left and the right-hand limits. So if we look at the limit as x comes to 0 from the left of f of g of x. Well, the limit on the inside does exist, so that's equal to f of the limit as x approaches 0 from the left of g of x. And as we see, as we come from the left of 0, our y value is headed towards 2. So this should be f of 2, which is, coming over here, 2. Okay, now we want to look at the right-handed limit. So we're going to look at the limit as x approaches 0 from the right of f of g of x, which again, if that right-handed limit exists, which it does, then we can plug in the limit here. X approaches 0 from the right of g of x and evaluate f there. So from the right, as we head towards 0 from the right, our y value is headed towards -2. So this should be f of -2. And coming over here to -2, if I plug -2 in, I also get 2. So because the left and the right-hand limits exist, this limit is in fact 2. Perfect. We'll stop there.